Well, good morning, everyone. I hope you had a good weekend and a good week last week. Made good use of your sort of snow day, I guess, or whatever that was that we had on Wednesday. Before we jump into new material for today, any questions, anything that would be helpful for us to go over here at the outset? All right. Well, that being the case, we were in the midst of last time we were together talking about the ABAP dictionary, and we talked about how we can use the ABAP dictionary to define domain data. Domain data gives us the ability to restrict acceptable values that would later be used in the definition of data types and other dictionary components. And last time we were together, we looked at how to create an individual data type. We didn't look at how to create a structure or an internal table in the ABAP dictionary, so I want to go through that really quickly. And then after that, we will make a transition to talking about database things, which will also have us in the ABAP dictionary as well. So we'll be spending a lot of our class time today in the ABAP dictionary. So the transaction code that gets us into the dictionary is SE11. And once again, last time we were here, we used it to create domain data, and we also created data types, and we'll create another couple of data types this morning together. This time we want to create a structured data type. So for the data type, I'm going to call this, we'll create a structure capable of storing someone's name. So we'll do ZN001 person struct, we'll call this. And so after putting in the name of the data type, we hit create, and we're prompted initially three different things. Are we creating an individual data element, which we've seen before, or are we creating a structure or a table type? And so this particular example, we're going to create a structure. So I'll choose structure, hit the check mark here, and then the screen is going to present me with the ability to specify the fields or components, as they're called in this particular screen, that will make up the structure. So the first thing I have to do is give this structure a description. So I'm going to call this information about a person. And then I come down here to the component, and this is where I'm going to specify the various fields here. So we'll have a field for first name, and we'll have a field for last name, and we'll have a field for middle initial. Now, you'll notice that we can put in as many different fields as we need here. We have a scroll button, so you could specify dozens of fields if that was necessary in a given application. But you'll notice for each field, we're asked how we want to type this particular field. And I'll show you the two options we have. First of all, we choose types from the typing method. When we get to objects, we'll look at type ref2. But for right now, all of these are going to be set to types. And we have two choices. If we type something here in the component type field, this is where we could use a data dictionary type. For example, if we wanted to use one that we had previously defined, I could search for data elements, and I could look for all of the ones that start with my username, because those are ones I've created previously. And so hypothetically, although this makes no sense in this given context, I could use this as the data type for first name. And obviously, as I said, this makes no sense at all because that's a data type related to ETSU buildings. But I'm just showing you how I could search for an existing data type. I can also do this. I can type in the name of a data type that has not yet been created. So I start everything with my ZN001, and I could create a new data type called first name type. And that does not exist. You'll notice it says here ZN001 first name type is not active. What I could then do is double click on this and it will ask me, do I want to create the type? And so I could say, yes, I do want to do that, and yes, I want to save this struct that I'm in the middle of creating. What package am I going to put this in? And search for the one that I have been using. Specify a transport request, and this now is going to be an individual data type, ZN001 first name, and so I'll just say that this is a data type for storing names, and I'm not going to use domain data here. Just to keep this nice and simple, I'm going to make this a character string that is 25 characters long. And so now I could save this. Have to maintain field labels, and so we'll do NM first name. See if it'll let me get by with just doing 3 of them. Activate this data type. So now that's been activated. So now I can go back and use that for my data type there. So we actually have 2 options here when we are specifying a data type for something in the context of a structure. And we're going to see this also when we move into data types for databases. If I use the component type field as it's showing here, that is a reference to a data type in the ABAP dictionary, which I could create at the same time I'm creating this structure using the technique I just showed you, where we type in a new data type name and then it will prompt me to create it. The other alternative is to use direct typing. And in order for me to do that, I have to click on this button right here called Predefined Type. And you'll notice the screen has changed a little. Instead of my being able to type in the component type field, it's been grayed out. And this region over here to the right is now white for me to be able to edit. And so I could come over here and do direct typing. And so I could say that last name is going to be a character string of type 30, and middle initial is going to be a character string of length 1. And we should always give descriptions for these. So this would be user last name, user middle initial. So when you're here in the data dictionary, you have 2 different ways that you can specify typing. You can do component typing, or you can do what we are doing right here, which is using predefined types, and you toggle back and forth with this button right here. So now I save this, I activate this, I'm going to get a warning related to the environment. Enhancement category is missing, and you find the enhancement category here under extras, enhancement category, and we just have to say that this can be enhanced, which means that at some point in the future this could be changed or extended if we wanted to do so. So we'll make that selection and then activate, and we've activated this fine now. So we could now use this ZN001 person struct as a data type for a structure in a program that we would write, and it has the 3 fields that you see specified here.
Where did you want to get the enhancement type?
Enhancement category is found under extras, enhancement category. Other questions? Yes, sir.
Do you use this more for local objects or for...
Everything here is global. Everything that we create in the ABAP dictionary It's global.
Name.
Yeah, I specified a package name, I had to specify a transport, I had to activate it, and so now anyone could use this particular data type in their program. Other questions? All right, I'm going to do this just to save some time. In a second, I'm going to copy this, because let's go out and let's look at, suppose we wanted to create an internal table. Okay, so ZN001, we'll call this a person table, and we'll create, and then this time we'll choose table type. So here in this situation now, the system recognizes that most of the time when you specify an internal table, your internal table is based on a structure. That's what we do when we define a standard or sorted or whatever have you table in the context of our program. So you'll notice my first option, which is chosen by default, is the line type, where here it's expecting me to put in, and I'll just paste this in, the name of a structure. So now what I am doing here is I am creating a type for some kind of table. We haven't specified what yet, whether it's sorted, standard, or whatever have you, but it is going to be a table of ZN001 person structs. Now we could, some of the other options here, reference types, we'll get to later. This would be a table of reference to objects. We could do a predefined type. This we talked about before. You could have a table of integers or a table of strings. We haven't seen any need for that. It's not very common, but that's what the second option there will do for us. Definitely should come up here and put in a description. So this is going to be a table type for storing people's names. I'll go ahead and save what I have put in. That's going to prompt me for a package and a transport. And then you'll notice here, if we just scan across here, initialization and access. So what kind of table is this? Is it a standard table? Is it a sorted table? Is it a hash table? Indexes we haven't talked about yet, not specified. Doesn't strike me as very useful. I think you would use that just for like work in progress until you came back to this and finished. Let's go ahead and say we're going to make this a sorted table. So I choose that for this tab, I'll save that, and then I go over, and now I have to specify other attributes of the table. I said that this was going to be a sorted table, so of course I'm going to have to specify things about the key. Well, we're going to use a standard key, and is it going to be unique or non-unique? And if we're going to do people's names, and all we have stored in the table is their names, and the key is not going to be unique at all. So we'll do non-unique. And then I have to come down here, and this is where I specify the individual fields that make up the key. And so let me save this, and I'm not sure why this is a bit odd here. It is not, all right, last name, it is not letting me edit this. Let's see what we've got going on here. Display to change. I've seen this happen before on my laptop because the screen is not wide enough because of resolution issues. Let me try and activate this. It's activated. Oh, I'm sorry. I have to pick key components. I wasn't thinking there. So what component in the field do I want to make the key? And so I'm going to insert a component here. So right here, we will make this sorted by last name. Yes, sir.
So the standard key, is that something where inside the structure itself you could potentially designate some kind of default key?
I think standard key would be used if this were like a table of integers. And so the sort order would just be the inherent value of the integer. So you wouldn't really be defining the sort order because it's a unary kind of table. There's just one thing in it. But when the table is made up of fields that have components, then you choose that as what you use to specify, which to me says that almost every time you're going to be picking key component there and specifying it. So notice we could, in this example, we could say we want to sort it by last name and then by first name. And that would be perfectly fine for us to do that. And we would save, and we'll try and activate this and see if we get any kind of warnings related to enhancement categories or anything. We do not. So we have now created a ZN001 person table. And the key thing is this is a data type. So I can now go into my program and do data, my table, ZN001 person table, and that would actually instantiate this as an internal table that's a sorted table with the fields that you see here. But this does not actually create the internal table. This creates the data type that could then be used in my program to create a table. Any questions about any of this? So if we go back to a slide that I had, a little pictorial diagram of this in our notes, let's talk about this for just a second, and then we'll pretty much be done with this particular slide set. In our ABAP program, we can use the data dictionary to create internal tables. You just have to do that. And most of the time when we create an internal table, it's going to be based on a line structure that is something that we created in the ABAP dictionary. And when we create a structure, we specify the components that make up that structure. We haven't talked about this, but you can actually have structures that have structures as their field. So for example, let's say that we had a structure called person info. And that particular structure had fields for first name, I'll just abbreviate here, first name, last name, and middle initial. So this is a structure type with 3 fields. I could then also create a structure called person detail, and one of the fields in here could be a reference to this structure. So I could have person info, and then I could have address, and then I could have zip code, and then I could have phone number. So in this case, you would actually see as the data type for one of the fields a reference to another structure that you've created. So although this isn't necessarily recursive, it does show here in our picture that you can actually use a structure in the creation of another structure. And when you deploy this in our program, let's say we were to create an instance of person detail. So we might have something like this, data P1 type person detail. And then I wanted to fill this with data. I could do P1 dash PI dash FN equals Bob, because I have to use the name of the structure, which is part of the person detail structure definition itself. So you can actually see a whole chain of these with dashes that are drilling down further into parts of a structure. Usually this is about as deep as you'll ever see a structure contained inside of another structure, but technically you can drill down as far as you would want to in a particular data structure that you might create. The other thing that's notable about this picture is, remember, we can create domain data in the data dictionary, but we cannot use domain data in our ABAP program. The domain data can be used to create data elements and all these other things that it's sitting on top of, but it cannot be used directly in the ABAP program. Questions? All right, well, give me a second here. Our next stop in our discussion is working with databases. So, we have done some work with databases already, and that you have used a select statement to go into a database table to pull out data to populate an internal table in our programs. Well, the first thing we will talk about here is kind of continuing our discussion of the ABAP dictionary is how could we create a database table in the SAP system. And the fact is, we do not create those programmatically. We cannot create a database table. We cannot drop a database table programmatically. We do all of that inside of the ABAP dictionary. So you well know from things that you have done elsewhere, a table consists of fields and or rows. In the ABAP dictionary, we have to give a table a name. We have to specify certain attributes of that table, including things as what are called delivery classes and maintenance authorizations. But we define database tables in ABAP systems using the ABAP dictionary. Now, a table, of course, as you know from other courses, a table will have one or more fields designated as primary keys that have to be unique on a per record basis. What we will see is very common in the creation of tables in the ABAP dictionary is table fields are commonly based on data elements, which are based on domain data. So if we think back to an example we did a few weeks ago where we were creating a domain data for what would be valid room numbers in this building. Well, if we had defined that domain and then created a table, a data type based on that domain, we could use that data type as the data type for one of the fields in our table. And I'll show you that here in just a moment. Table fields may be typed without reference to a data element. We can do direct typing, which I just showed you in the context of a structure. I'll show you this again. This is where we can say, well, this is a string that's 24 characters long, or this is a numeric string. But in this situation, we don't leverage data types, so we can't make reference to domain data, so we don't get the automatic checking that we get with usage of other data types. Tables have technical settings which govern how the system optimizes the data storage. This is based on questions like, how big is this table expected to be? Should the table be buffered? Should changes to the table be logged? Those are all different things that we can specify when we actually create a table in the ABAP dictionary. Let me go over one set of facts and then we'll actually walk through this. When we go into the ABAP dictionary and define a table, what we are actually doing is called creating a transparent table. A transparent table becomes a real database table when we activate it. So we'll go through and we'll define the structure of a database table and we'll save our work as we're going along. But at that point, the database table has not been created. When we hit the activate button to activate it, at that point, the database table gets created in the underlying database management system. Here's some things you know or will know. The database specific table will have the same name as the ABAP dictionary transparent table. So there's a one-to-one correspondence on the name. The field types in the DBMS specific table are converted to whatever appropriate data type definition is in the database management system. Now, what do I mean by that? Well, let's think about our architecture here. We are working in ABAP, which if we think about our three-layered architecture, we have the presentation layer, we have the application layer, and we have the database layer. Well, when we do our work, as we say here, we're going to go into the ABAP dictionary, we're actually working on the application layer. So we open up the ABAP dictionary on the application layer, we do all of the definitions, we create the transparent table. When we hit the execute button, the application layer, the activate button, the application layer is going to go down to the database layer, and it's going to create the database table. Now, in my application layer, I might have created a data type called ZN001, XYZ. And that's a data type that I have created that's tied to domain data called ZN001 domain. Well, the database doesn't know these data types. So what's going to happen is the application layer is going to go down to the database layer, and it's going to create a type for this field based on whatever the best type is for whatever database system this is. Because this could be an Oracle system, this could be an IBM system, it could be any number of different database systems. So the activation process is actually going to translate what we have defined in the ABAP dictionary into the appropriate database vendor specific specification when this table is actually created. The underlying elements, therefore, may actually be changed in the implementation, because ABAP does some interesting things at times related to field optimizations. So the bottom line is there is correspondence here between the application and the database layer, but we will never, ever, ever interact with the database layer directly. We always interact with the database layer through the application layer so that this integrity is maintained. So this integrity is being maintained partly by the database layer and partly by the application layer as it monitors the data that's actually put into the table and how the database table is defined on the underlying technical element, on the underlying technical domain. So here's a fancy way of saying that. The transparent table in the ABAP dictionary is the database independent representation of the underlying table, and its definition is used in ABAP programming. And then I made this observation before. The only way we can create tables is in the ABAP dictionary. They cannot be created programmatically. So let's create a database table. So we come out here to our main screen of our ABAP dictionary. This is transaction code SE11. And you'll notice one of my radio buttons here is for a database table. Remember, we're creating things that are global in scope, so we have to start these with our username without the dash in order to avoid name collision and other things of that sort. And so I'm going to create, just as an initial example here, let's create a database table capable of storing people's names. So I'm going to call this ZN001 people. And I will hit create. Okay, so first screen that I'm at asks me about some of the things that I mentioned a moment ago, which is delivery class, maintenance, and things of that sort. So if I click on delivery class here and look at my choices, it wants to know basic attributes of the table, such as, is this an application table, meaning is it going to store master data and transaction data? Is it a customizing table, meaning that we can use it and the table will be maintained by us, but SAP when it does updates, is not going to touch this table. Is this a table for storing temporary data? That's going to influence where it's actually stored on the system, because it's not going to be integrated into storage in the same way if this is only going to be a temporary data table. Is it a customizing table, which also is protected against SAP updates? But this is a table that you can only insert into. So you can't delete from or update. An example of this might be something like a log file table, where you're just inserting log file entries, but the log file would never be deleted for audit purposes. And you can see there are other specialized tables here, control tables, system tables, which can only be maintained by SAP, so we can't pick that one. And so for our purposes, we will use an application table, because this is a table we're creating to use in our application. So almost every time we choose something here, it would be that. And you'll notice our options here, we're going to allow display and maintenance with restrictions. We could change this display maintenance allowed, which gets rid of the restrictions, or the key thing here, display and maintenance not allowed. So this would be a way that you could actually come in and edit an existing table to make it not usable anymore. Don't know why you'd pick, when you're first creating it, display and maintenance not allowed. So we'll just leave the initial display maintenance allowed with restrictions. That will be fine. So I'm going to save this. Whoops, I forgot to put in a description. Information about people. And then I come to fields. Now, for reasons that we will discuss more in our discussion in this section that we're in now, you will almost always want your very first field in your database table to be the Mont field. And we spell it exactly like you see here. It is a key field, so I put a check mark next to key next to it. Initialized means it can't be null, and this is a field that can't be null. And then the data element for this is the same as the name of the field. It is Mont as well. So you will almost always put that in as part of the key for your particular table. Well, now we put in other fields that are going to make up our table. Let's assume this is for use here at ETSU, so we're going to do this. We're going to do eNumber as the name of a database table field, and we will make that part of the key, because that is going to be unique, and we have to have a value for that. And then we'll do this. We'll do first name, last name, and middle initial. None of these will be part of the key, and we will say that a person has to have a first name and a last name, although middle initial could be left blank. So now I have to come over here and specify data types. Well, just to review what we did a second ago, let's do this for eNumber. So I'm going to say I want to create a data type called ZN001 enum type, which I don't think we've created to this point. So I'll type that in there, and as soon as I hit enter, it says that type is not active, so let's create it. So now I come here, yes, save, yes, and now I'm going to create this particular data type. And what I'm going to do, and you can get lost really easy when you do this, so you got to think through this. I want to make this based on a domain. So I'm going to come here and I'm going to just give it this as a ETSU eNumber type definition. And this is going to be based on a domain. So this is going to be ZN001 eNumber domain, which also has not yet been defined. So as soon as I hit enter here, now it's going to tell me, after it thinks about this for quite a bit, hold on a second, you're asking me to use a domain that doesn't exist, and it's having to think really, really hard. Hopefully we have not lost a connection with the server. which we have lost a connection to the server. So that's just a glorious thing to have happen right here in the middle of all of this. So what we will do is hopefully remember what it was we were just creating. So I guess if you ever have this happen in your work, you'll at least have seen how we recover from this. So I'm going to terminate the login that I terminate my existing login, which is not what I wanted to do. Okay, continue with this logon and end the other. Okay, SE11.
How is there like a standard time for how long before you lose connection?
In this case right here, there's not. I have at home, like, been logged into the system, gone to bed, woken up the next morning, and I'm still logged in and active. But I'm not on Wi-Fi. On Wi-Fi, if you're on a flaky Wi-Fi signal and you lose Wi-Fi connection for like half a second, you could lose your connection. So it's just totally a function of that. So what I'm going to do here is I'm going to go back into my ZN001 people table, and I'm going to change it. And you'll see I'm back here now, and we'll just kind of chase down this pathway as we did a second ago. So I'll double click on that and that data type. And remember, I didn't get a chance to click on save here. So this is going to be ETSU number type, and we're going to create ZN001 number domain. So let me save this time, so this will still be here, and I'm just going to do this. This gets annoying after a while. EN2. See if it'll let me get away with just doing that. Okay. Activate. Error occurred when activating. Data element is inconsistent. That's because I haven't yet defined my data type. Okay, so here finally now I'm ready to define the domain for enumber domain, and we'll say that this is a numeric string, numerical text. Anybody know right off how many characters is in an enumber? Is it 8? What? Is it 9? And we're not going to get into, we could actually create it where the E would be part of it. We're just going to keep this real simple and say that it's a 9-character numeric string, so we're not going to store the E as a part of it. And so I'll activate this. Is it 8? Okay, well, let's see if we can go ahead, we'll change it to 8. Okay, so now I have created the domain, and I will back up, and now here's my data type. So now that I've done that, I should be able to activate this, which I did. So now I back up one more time, and now I have defined that as my data type for my field in the database. Okay? And we're going to keep the rest of this really simple. For first name, last name, and middle initial, we're going to just use predefined types. This is my other alternative here, and so I'm going to say that first name is going to be a simple character string. Last name is going to be a character string, and middle initial is going to be a char. And of course, middle initial we'll say is 1 character long, and we'll let first name and last name be 30 characters, and first name, last name, middle initial. Okay, so in theory, I've specified this number of positions less than minimum number of positions for, oh, well, apparently if you specify string, then The smallest possible string is 256 characters long. That's longer than I want for a first name. So let's just make this a char character string. And it's going to tell me the same thing here for this one. And so I'll make this a char character string so that I can do 30 and save without incident. Yes, sir.
For string, what happens if you don't put a link? Because string is a complete data type, right? So normally, like when you're writing a statement, you wouldn't have to designate a link.
So I'm glad you asked that, because it's important to realize that the definition of string and the definition of the other data types here are not the same as the definition in our ABAP programs. In our ABAP program, string is a dynamic data type of variable length. As we just saw here, in creating a database table, string is a data type that's dynamic but has a minimum length of 256 as far as the defined length. Now, I could still use it for first name, and the user could still have a first name of Bob, but 256 characters are going to be reserved in storage for every one of those, which is definitely overkill and why I would want to pick something a little bit better, like we did here. All right, so let's see, and if we can activate this, or if there are things we still have to specify, and there are going to be some things we still have to specify. So actually, nicely enough, when I went to activate, instead of it giving me an error, it took me to this screen where it says, okay, tell me some other things about this table. Data class. And all of these, you'll notice, have search fields next to it. So I pull up the search field, and it asks me again, okay, what kind of table is this? Is it master data? Is it transaction data? Is it organization and customizing data? Or is this a dimension table in a data warehouse? And we'll say this is going to store master data, be a transparent data type. Size category. Here it wants us to estimate about how many records do we think this table might ultimately have in it. And this is going to help it figure out how to allocate storage for it. And notice we have data types that go all the way up to 690 million records. That doesn't mean that's the high end, but it means that's the largest that you can specify here for it to allocate space for initially. Well, you will be happy to know that in none of our database programs are we going to be manipulating 690 million records. So for this class, we'll pretty much always pick size category 0 because our tables are going to be pretty small. Buffering, we'll go ahead and leave it as buffering not allowed just to avoid creating overhead. Buffering means in this context that if this table starts getting used by the system a lot, the system will automatically move it into high performance memory and will cache a lot of the database table information for speed purposes. We don't need that, so we'll just say buffering is not allowed. And so since we pick that, we don't have to specify the buffering type. Do not turn on logging data. If we turned on logging data, that would mean that anytime any body or any program hit this table, all of that activity would be logged into log files. That has the potential to generate a lot of log file activity. So one of the things that we observe now, I think for the very first time ever, is every database table has the ability to log information about who accessed it, when, what did they do, and all of that. But that is optional. When the table is created, you get to define whether or not you want that to be logged, or you could come back in after the fact and turn logging on or off. We will not turn on logging, and we will not be writing to this table only with Java, so we don't toggle that on. So we will now save these technical settings, and we'll go back and try and activate again. Notice it says warnings. Let's look at what the system says. Enhancement category for table is missing. So we saw this a moment ago where I go up to extras and choose enhancement category, and I'm going to take care of this. We'll just say this can be enhanced, And we'll try and activate again. And the object was activated. So now, in the underlying database, there is a system called ZN001, we call this people, and it has the fields that you see there. The key thing to keep in mind is, if we were to look in the underlying database directly, which we never do, but if we had sysadmin privileges on that database, we would be able to find this table, and we would be able to find these fields in that table, but all of this stuff might look very different because it would be translated to the appropriate underlying database code. So some of these might have been changed into varchars, for example, or other database types that would be system dependent. Any questions about this? So one of the things you will do for your next homework assignment is actually create a database table, and we'll fill it with information and you'll work with it and things of that sort. This is how you create database tables in SAP. It's a lot of, I mean, where it gets tricky is you're creating database table and you're going to create your own types, and your types are going to be based on domain data. I mean, it can take a lot. That's where you really want to, unlike what we did here, you'd really want to sit down with a piece of paper and probably work out your design first, and then go in and do the implementation as opposed to doing it on the fly here. But the other part of it is, although you do find the need to create database tables from time to time, it's not something that, you know, developers do like on a daily basis. Okay, so what has happened here is actually this. So now let's talk about how the interaction with the database works. And I kind of put a little bit of this on the whiteboard a moment ago. But we have, of course, the presentation layer, the application layer, and the database layer. Well, when we start working with the database layer, on the application layer, there's something called an ABAP dispatcher. And the ABAP dispatcher spawns work processes, which you can think of as being like threads in a multi-threaded environment. The ABAP dispatcher is going to spin up a work process that then is going to be used for our ABAP program. And so this work process, which there's a buffer here that can be used for moving data back and forth, is going to reach out to the database layer and activate the database work process there. And that work process then will perhaps go out to the database disks or wherever the storage is. It's going to retrieve the information from the database disks, grab it, pass it back to our work process, which then ultimately may result in things being painted on the screen or otherwise presented on the presentation layer. But the big thing I want to make sure that we understand is we never go into this database layer directly for any kind of table maintenance work. We always go through the application layer. And I think we've talked about this before, but just to emphasize it, the reason for this is, let's say this is an Oracle database, and let's say I am the Oracle database administrator. So I have super user privileges. And I go into the command console and I start deleting records from database tables. Well, as soon as I do that, I have undermined the integrity of this entire system. Because if you think about this from an accounting perspective, in accounting we have to have financial controls, we have to have debits equaling credits, we can't have money just disappearing. Well, if you're a super user of the Oracle database, you could go in and write some SQL commands that would change the balance of certain accounts or move money from one place to another, which clearly we don't want to have happening because that's usually the way that things like fraud and theft and other things are done. So inherent in this is these databases operate in what's called the sealed environment, which means a database administrator could come in and back up the database. They could come in and do things like mirror the database to another location. They could even do certain kinds of performance tuning operations. But as soon as they go into database tables and start messing around with data, there are all kinds of flags in the system that are going to be triggered that will indicate that our database is now unsealed, and this is a fraud warning to auditors. And so when auditors come in, and if they see that, there's going to be a world of trouble. And in fact, in a lot of environments, this will be reported back to SAP, and SAP, somewhere in their documentation, basically says, if you ever unseal your database, don't expect us to ever offer you support again. This voids your relationship with us, because that's the way companies commit fraudulent activities. So we only manipulate data in the database by working through the application layer. Any questions about that? All right. So let's get into a little bit more of the technical elements here. SAP ERP uses OpenSQL in ABAP statements. OpenSQL is a vendor-neutral variant on SQL. So what you're going to see here is SQL statements that look a lot like what you learned in your database classes, with just a few probably odd differences that you have to get used to here. Here's something with a big old exclamation mark next to it. You can write native SQL. Native SQL means that, for example, I know that my company has Oracle as its underlying database. And I know that Oracle has a particular function that's not a part of OpenSQL. And I want to use that function in a query I'm going to write. I can structure the syntax of the query and say, in essence, I know this isn't valid OpenSQL, but feed this to the database exactly as I have written it, and ABAP will let you do that. That's called native SQL. But the problem is, what happens 5, 10, 15 years from now when my company decides that they no longer want to use Oracle, and maybe they want to move to SAP HANA, or maybe they want to move to an IBM database? My code is now broken. And in fact, what has happened to a lot of companies is they weren't really hard-nosed about making their employees write OpenSQL. And so some of their employees wrote native SQL, and then they upgraded or updated their database, and their system stopped working. And that's a recipe for a big problem. So although you can write native SQL, you really should never ever do that, because it's like loading a gun and assuming that at some point it's going to go off and shoot someone in the face, and it may wind up being you, so you don't want to do any of that. And as a point of fact, a lot of companies right now are migrating to HANA away from Oracle or IBM systems, and this is one of the things they're having to clean up. And it's delaying their ability to actually move to some of the newer technology. And so this can be a real pain point down the road. So as I was saying just a moment ago, you want to write OpenSQL statements, and you're going to find that it mirrors traditional SQL, but there are going to be a few subtle differences, a few refinements that we have to get used to. So OpenSQL is just a data manipulation language. We do not have DDL operations. Why? Well, as we just observed, you can't create a new table. You cannot drop a table. You cannot do other data definition operations inside an ABAP program, because that's all done in the ABAP dictionary. So all of the commands you know about creating tables and changing the structure of tables and dropping tables, all that goes away in OpenSQL. So OpenSQL pretty much just focuses on the 4 commands that make up data manipulation language, that being select, update, insert, and delete. And so we'll talk about those. Now, one of the things that we will want to get used to is the use of sy-subrc. Remember, sy is that system maintained structure that contains values depending upon what's going on in the ABAP environment. Anytime we interact with the database, we can check sy-subrc to see if the operation was successful. And this is one of those things that is good habit and something we definitely should do, but it's going to be hard for you to test this in our environment. Let me explain what I'm talking about. Let's say that we ask the database to insert a new record into the database table. And we want to find out, did it do that? So what we should do is we should do our database insertion, and the next thing we should do is check the value of sy-subrc. If it is 0, that means what you just asked the database to do, it did. If it's something other than 0, that's an error code. And I'll cover what some of those error codes mean, because it depends on what command you just issued. The reason why this is challenging in our program is, why would you see an error condition? Well, assuming your program is written properly, you'll see error conditions, for example, if the database is offline. Well, there's no way in our class environment for us to simulate the database being offline. So you will get in the habit of testing sy-subrc and writing conditional code for how you handle an error condition. And in fact, unless something really, really bizarre happens, you'll never see a value other than 0 in our environment. But in a real production environment, you might have an instance where the database crashes. And what you don't want to have happen is you don't want to have a program that runs and puts 50 records in a database table and issues 50 insert statements and then shuts down and says, yay, my work is done. And none of that went into the database because the database is down. So we want to get in the habit of never assuming success. Every time we send a command to the database, we check sy-subrc and make sure that in fact it was successful. Now, there's another value that we can check as well. sy-db count is set to the number of records affected by the last operation. So let me give you an example of how these are two different things. Maybe the zip code here in Johnson City changes from whatever it is, 37615 to 37624. So we're going to go in and we're going to use an update statement to update the zip code of everyone that lives in Johnson City to this new zip code. Well, we can issue the update statement, check sy-subrc to see if it was done correctly, and we get back a 0 and we're like, yay, it was done correctly. But we could also check sy-db count and it might tell us that 847 records were adjusted. Now, if you think about that, we could have just done the update and then checked sy-db count to see if we got a number greater than 0. And if we saw a number greater than 0, then we would know that's successful. So sometimes you can get away with not checking sy-subrc and instead can check sy-db count. You could, for example, have an update that affects 0 records, but it was still a successful database operation. There was just no work to be done. So you really have to think about the context of the command that you sent to the database in terms of which of these makes the most sense for you to check. But the rule of thumb, and you want to write this down and make sure you do this in all of your homework programs from this point forward, anytime we do anything with the database, after we send a command to the database, we always want to check for success before we plow ahead with whatever is next in the logic of our program. So let's start with the obvious first statement for us to start with, the select statement. Select statement's broken up into 4 clauses. We can have select, we can add the word single, which I'll talk about in a moment. We can use a star here if we want all the fields, or we can list the fields that we want to be selected from the targeted database table. And this is pretty straightforward. This is going to determine the fields to be retrieved. Select star gives us all of them. Select, listing the fields, gives us a subset. If I specify select single, then the system is going to go out and find the first match. And then it's going to stop looking. The merit of this is what? Why would you perhaps want to use a select single in certain instances? What is this going to do for us in our programs?
Distinct, if those are valid tokens.
I could see an instance of what you're talking about being useful. I don't know that that's the primary reason why we use this. Anybody think of another reason? Why would you ever want to tell the database to just find one and then stop looking? What's the inherent benefit in that? Okay, it's a quick check if it exists. That's true. What else comes into play there? I've kind of given you the answer in the question. It stops looking, okay? So you have a database with 50 million records in it. It's all of your customers. You know that a given customer only exists once in the database. If you do a normal select, star from customer table where customer ID equals 1, 2, 3, 4, 5, 6, 7, it's going to look through every record in the database and pull back matches. Well, what happens if it finds your customer in the 3rd record of the table? Well, that's great, but it's going to keep checking all the other records. But if you know there's only going to be one match and you say select single, then once it finds one, it's going to stop looking. So whenever possible, we do want to get in the habit of using select single for efficiency purposes. So we have the select part of the select statement from database table. That's pretty straightforward. That will either be an SAP system table or a database table that we have created, specified there. Into, and we'll almost always use into corresponding fields of, although we may find that we don't have to use that in certain instances. We may have the keyword table listed there, and then where this is going. So this is going to specify where the results will be stored. Now, if you think about this for a moment, if I'm doing a select single, the target could go into, well, it depends on what I have listed there for fields. If I have select single star, so I'm bringing back a whole bunch of fields, but I'm only bringing back one record, well, that could go into a structure. That could go into something like a work area. But if this is a select not single, so I could be bringing back a whole set of records, then in a lot of instances, we're going to put this into an internal table. And if it's going into an internal table, then I have to put the keyword table there. Maybe I'm not retrieving the entire table, so we might see something like select first name space last name from person table into corresponding fields of table, my internal table, or something to that effect. So this reference to the word table here is associated with using an internal table for the result set. Results are loaded left to right. So this is where you have to be really, really careful, or, like I've advised you to do previously, just use the corresponding fields of. In theory, if you are very, very careful, and you were to do select first name, last name, middle initial. And you were going to retrieve this into an internal table, and the order of the fields in the internal table were FN, LN, and MI. So you had an exact left to right match, then you wouldn't have to use into corresponding fields of table. But if at some point in here, things got a little bit out of order, and you actually did this, like LN, FN, MI, and then you fed it into this, well, you're not going to get a syntax error, you're not going to get any kind of error, it's just your program's going to work really, really oddly. So what protects us from this is corresponding fields up, because corresponding fields up will then just match these up. So once again, it's insurance against shooting yourself in the foot, which is always a good thing to incorporate into our programs. Can be retrieved into individual data objects, and I'll show you this a little bit later by using the into clause. So for example, I could do select single, first name, last name, middle initial, from blah, 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 into, and then I could say put this into data objects ln, fn, ni, which are individual data objects that I have created in my program. So it's not even going into a structure in this situation, it's going into discrete individual data objects. We'll look at the code, we'll look at examples of all of this here in just a few minutes and when we get together later this week. The where condition looks like what you have seen in SQL you have written before, although we'll talk about some of the unique facets to that as we go along. Specifies which rows are to be chosen by the selection criteria specified. SUBRC. If it's 0, that means we have success. That's universally true. Other common error numbers you will see is if you see a 4, that means you didn't get back anything. Empty result set, no data found. So you could execute a select statement, and usually what we'll do is we'll structure the logic to say if sy-subrc does not equal 0, then we trigger some kind of error handling. Questions?
Are all the codes listed in the documentation for that?
They are. If you were to actually go into, and we're headed here next, so this is a good time for me to, if we go to SE80 and we start writing a program, and so in my program I'm going to have a select statement, function F1. If I look up in the help here, select ABAP statement, in the documentation that appears, you're going to see a recap of all the different options here, and somewhere in the documentation, if we scan through, yeah, here's the sy-subrc 0, everything was successful, 4 results set are empty, 8 in the addition of 4, which the primary key is not fully specified. So you can see it's not like there are dozens of these, but there are usually a few different values that have a particular meaning in a given context. And yes, the documentation is your guide for that. So let's look at a simple example. So I create an internal table, and you'll notice that I'm making it to match up with the structure of the SPFly table. Data ITAB, type table of SPFly. By the way, notice I can get away with this. What I have gotten in this situation is a standard table with no key fields. So that's kind of the most abbreviated table, internal table statement we could use. Data WA like line of ITAB. And then I do a select statement. Select Mont, Carid, Conid, city to, from SP Fly into corresponding fields of table ITAB. Okay, so we know that my internal table matches SP Fly, but it would seem, because I've listed I've listed a set of fields here, that I'm not necessarily retrieving all of the fields. So that's why I did not use select star. And to save myself from shooting myself in the foot, I did go ahead and put the into corresponding fields up. I will just make the observation for now, and we'll probably talk about this on Wednesday. It is very, very unusual to retrieve the Mont field. I'm just showing it to you here in this example because it is something that technically you could retrieve from the database table, but usually we will not find the need to touch that at all in our ABAP database programming. And so this is code we have seen before. Loop at ITAB into WA, and then I'm writing that out to the screen and ending my loop. So this is illustrating by way of the select statement. We have no where clause, so we're retrieving all of the records, just the field specified, from the given database table. Any questions about that? All right, so let's talk about the where clause in a little bit more detail. We can test for strict equality or match using either the equal sign or EQ. And I will go ahead and clue you into this. This is not, in the case of strings, case sensitive. So OpenSQL does not have case sensitivity. So if you're looking to match up Bob with a capital letter B versus Bob with a lowercase b, this is not going to allow you to distinguish that. You're going to have to figure out another way to make that distinguishment in the actual logic of your program. You can use a wildcard by, instead of using the keyword or the key symbol equal or EQ, you can do like. And in creating a like pattern, an underscore matches a single character. $sign matches a string of any given length. So you could do something like where ln like underscore t %. And that's going to match every record where the third letter in the last name is T. So these are the wildcard symbols that we use in OpenSQL. So here would be an example of something like that. This is where the second letter of a given field. We do have, and we'll just leave it at this, there are functions that can be used in your queries. And you can see page 478 in your textbook for a listing of some of the functions that you can incorporate into a select statement. The next thing that we are set to talk about is a feature that is new in ABAP that will change even some of the programs that we have written to this point and actually enable us to make our programs much simpler. But to do it justice, we need more than the 2 minutes we have left, so we'll hold on to that until Wednesday. My plan is, barring snow or apocalypse or meteorites or whatever, for us to meet on Wednesday, continue this discussion, and then give you your next homework assignment on Wednesday to be done over the next few days. If you did not sign in, the sign-in sheet looks like it's up here. Please make sure you do that. And then note my observation on the board. Make sure you go in and look at your exam and check the scoring, look at all the questions you missed. And if you notice any issues, let me know. Do that sometime this week before your ability to look at that closes. Have a good afternoon, everyone.